So, Monday afternoon. Hello, all. We just landed a probe on Mars. I think it's about the 7th probe sent there. Two others are collecting geophysical data about the surface, and this one's going to basically detect subsurface temperatures and strata using a single sensor that matches what's in LIGO. Just one of the sensors. So they're using a single detector and they're going to do some type of geological mapping, which is way cool stuff. So it begs a question though, what does LIGO see? So that was from a previous video. I've gotten a little bit of noise back about it's just noise, but you don't understand detector physics and data discrimination if you make that simple a statement. So just from the sheer amount of data they're collecting, there's something there, period. What it is would have to be interpreted, and that takes more than someone with a computer and an opinion. But hey, another point, that Geiger counter sitting up behind me, you can see it reading something. So it's just on and it's stationary. I see a lot of noise about what these detectors can and can't do and how they're used, and that's tough to say because there's a lot of ways to use these meters. But because it takes 1 minute to collect a sample of, say, 30 counts average for this location, that sample window matters. The meter inaccuracy matters. So you have to take long periods of time, period averaging, in order to use this data to interpret the data with any meaning. So it takes large data sets. If you're doing stationary readings, even if you're doing moving readings, the data sets end up being the same size. So this meter, this detector, is truly meant to use a 1 minute sample range. That's typically how it's used in a scientific application if you were doing some true measurements with this, and you can. So understanding the measurement requirements, the time requirements, when you get somewhere you have to be willing to sit for at least 10 minutes and get a good reading, unless you really trust the meter and depending on what the meter's doing. Now this meter is collecting 5-second samples, which means it's only getting a sample size of 8 to 10 counts, depending on the total counts. It's getting 6 counts in its sample, but it also provides a running average or a running total of a full minute's worth of data in its log. So you've got to be able to open those data sets up and analyze them and start looking for changes that are not normal. And you do this whether you're doing a moving data set or a stationary data set. So how the meter collects data, 1 minute averaging, 1 minute sampling, is important to understand when you go back to look at the data, or you can confuse yourself really quickly, just like I'm doing mental gymnastics now trying to explain it. So yeah, these are very powerful meters. These are laboratory standard meters, unless you've got some hokey thing off the wall that hasn't been studied and looked at and engineered. So, but the meter itself will tell you if it's working. Is it stable? Does it do stupid things? Does it react to a microwave turned on in the house? Does it react to a local radar set? Can you walk near a huge transformer and does the meter change? If it is, then you have to stay away from those things, or you're going to get bad readings. In this case, whatever I do gets logged and posted to a website, and if the readings are too hokey, they get called or they get questioned, asked why. So I upload data sets that never get posted because I say not to post them because it's stationary data. There might be quirks in there that I don't see, but there's just the analytics you can do on these data sets is interesting, maybe, and it is also science. It's evidence. Is if you go look at the safecast.org Fukushima area map, that's not safe, and using these simple meters to show it means they need better meters. Kids are playing, people are going to live there. The increase in cancer is documented. For every 1 sievert dosage, it's a 6% population increase in cancer. So those kinds of numbers exist under there. They're in papers. They're in lots of papers that are peer-reviewed and studied and meet all the noise that some people like to hear. And you can go find these things. So, yeah, what we measure matters. We measure a lot. The USGS is probably the largest repository of information on the planet, and that information is sold to all kinds of organizations to do whatever they organize, and that's part of life. It's what makes this video possible. So there it is. But we measure stuff, we have a right to know about it. So that's kind of what I'm trying to imply here. To these meters, in order to make them more effective, if you're going to do sampling, you have to isolate them from the environment and try to get the background noise as low as possible. You have to take it out of the case so it's able to measure alpha and beta particles, which it can't do in that case. So knowing what the meter can and can't do is important. The attenuation will tell you what kind of particles are in the air. If you put a thin film of paper over your detector, thin piece of plastic, and it significantly changes the counts, you have a lot of alpha radiation in the air, which means those particles are in the air and they're very inhalable. Now you've changed from external dosage to internal dosage, and now you run that 6% increase to the population in cancer rates, from thyroid problems to colds and flu-like symptoms. That's the side effects of these. So I'm not afraid of this stuff. This is just how it frigging works. It's well documented. We've got decades of studying it. I sample randomly, and I haven't been traveling much, but I've got lots of records out there just about the environment today. It's hard to go back and look at them and make sense, but the SafeCap map has the data. So it's part of a bigger standard data set that is reasonably accepted. If the colors are red, there's a problem there. That's abnormal. I don't care whether you call it temporary normal or what. So descriptions are important, but you have to understand them. So yeah, that little meter is logging against uniform time code, so it's got a timestamp based upon a standard across the globe. Don't have to worry about time zone changes and such. So that type of data is solid in there, and the GPS's accuracy is reasonable. It looks like it's set up for moving. It does much better when it's moving than stationary, but I've even got statistics on GPS stability if people like to do that stuff. So, but that meter's meant to travel. That's the best thing for it, is to be on the road somewhere for a while. Safecast.org.